So today we are going to learn about algorithms. All right, so to start off, everybody spend 5 minutes Googling what an algorithm actually is. And then I want y'all to just give me your takeaways. Let's make it 2 minutes. I don't think we need 5 minutes to Google what an algorithm is.
I think you said Slack it over to you, right?
No, you could just call it out. Unless you'd rather Slack it over. You can put it in the chat if you feel like you don't want to call it out, but I won't judge either way. I don't think this is one of those things that it has a super strict definition. So it's more of like, let's figure out what people are talking about when they talk about algorithms. I'm going to give y'all 19 seconds. And we are at time. Okay, so what is an algorithm? Somebody tell me what that is.
I got that it's a set of guidelines that describe how to perform a task or solve a problem.
Set of guidelines describes how to perform a task. Cool, love it. Anything else?
Like someone compared it to being kind of like a recipe. It's essentially like the steps you take to solve a problem.
Cool, awesome. Cool. Now I'm going to throw a buzzword at you, give you another 2 minutes to look something up, and we're going to see what you come up with. The next buzzword is big O notation. Floop-de-dee-floop. Got it. Cool. Whatever. Big O notation. 2 minutes on the clock. Set timer for 2 minutes.
You'll need to unlock your iPhone first.
Whatever. 2 minutes. Bam. And while that's going, I feel like I said I was going to do this, and I feel the responsibility to do so. Eddie Van Halen apparently died recently, so we gotta make tribute. This is it's one of those songs that everybody wants to learn when they're 13 on guitar. At least the cool part of it. Get to the cool. Where's it? There we go. Okay. Hopefully you guys got to enjoy some Eddie Van Halen there. All right, so what is big O notation? Somebody let me know what that is.
It's
It's
like
a
the
system that
time.
I go ahead.
That's all right, Brian. Go for it. All that pause and we started talking at the same time.
It's just a system used to describe the time or space complexity that a particular solution requires for solving a problem.
Used to describe time or space complexity. Great, love it. Any other thoughts?
I saw one thing that it said it focuses more on like the worst case scenario as far as like how much time it takes in the space.
Scenario. I think that we can improve this. So you're right, but I think that what is worst case scenario as defined in big O complexity? It's as something in the function grows. What?
The input.
Yep, it's as the input grows in length, right?
Yeah.
So focus is on what happens as the input grows in length. So for example, let's start with an array of one term versus an array of 5 million terms. Right? Cool. What else about Big O? Anything else?
So I kind of think of it as it's like a tool to have us assess how effective our code is.
Love it. And just to expand on that, I would say tool to assess how effective our code is when the inputs get fucking huge. Cool. Now today we're going to go and we're going to look at a pretty simple Big O problem that's not crazy. Oh, and let me check the chats too. This is like watching Kyle Coverly code. Oh, because he. Oh, that's a good one. Love it. Cool. How far? Oh, is that AJ? Nice.
No, it's the other Flatiron grad.
Oh, the other one. Nice. AJ is a very handsome man. Let's look at that. Let's look at this art. For anyone watching this video in the future, you should check out this article. AJ, I didn't know his real name was Alexander Jesse. What do you know? You learn something new every day. Good dude. Good programmer. All righty. So let's see what else we got in this chat. Oh, yeah, this is all just banter in the chat. I thought maybe there was something like some answers to Big O, but turns out that happened to just be a distraction there. So we're going to talk about a problem. Let's say I have a game that I put online. And on this game, I can have a score between 1 and 100. My score, let's make some my problem. So a user can score between 1 and 100 points. My game has thousands of users that play all day because they have no life. Okay? Which means that each user is submitting hundreds of scores every day. I need to make a leaderboard for the top 50 scores. How would y'all do this? what I'm going to do is I'm actually going to put 10 minutes on the clock and give y'all the opportunity to give this a shot. So for now, we're going to start with a simple problem. We are going to take an array, my scores. This is going to look, for now, we're going to do 10 scores, and we want the top 5. So we're going to make a score of 10, a score of 5, a score of 3, 2, a score of 3, 7, 9, 9, 1, 2, 3, 4, 5, 6, 7. Yeah, we'll do.
And your players suck.
I don't even know how hard this game is. This could be the hardest game in the world.
Can't be that hard.
And we are going to say that for this game, our max score equals 10. So this is like, we're gonna make a simpler example, because in reality, in our function, we're gonna want to be able to adjust the max score, and we're gonna be able to adjust the amount of scores we're listing. Okay? So for now, we're gonna say max score. So between 1 and 100 points, and this is just an example of it. We'll call that the max score equals 100 for that example. But we're going to do a simpler example first so we can break it down. My game has thousands of users, so that means that I'll have an array of 1,000 scores. Scores. And then each user is submitting hundreds of scores every day. Cool. So that means that scores, that means that it's growing fast. We don't need to really write anything there. And then we need to make a leaderboard of top 50 scores. So we'll say amount on leaderboard equals 50. So amount of leaderboard should be a variable in your function. Max score should be a variable in your function. Your function will have inputs. We'll call the function, will be called, I don't know, let's call it leaderboard. And it will have inputs. Input arguments will be max score. We'll have a, let's see, max score, amount presented, and then we will also have a, obviously like the scores array. Okay. What I want y'all to do is let's try and find a solution to this. So I'm going to give y'all 10 minutes on the clock. I'm going to put you into breakout rooms, and you're going to try and find a solution. And then
what's amount presented?
The amount, like let's say the top 5 scores, top 3 scores, top 2 scores. How many scores will my leaderboard have? For example, a great game that I can think of that has a leaderboard would be this wonderful View app developed by an excellent student for their capstone, which I have to wait for it to load because the student, you know, while being amazing at coding, didn't really want to put money into making Heroku keep his stuff deployed all the time. So let's say I go here. More than 20 people have played this game, but it's only showing the top 20 scores. So that would be like your amount shown. Okay? That one's more complicated than our example. Sorry. That was not Van Halen. All right, so I'm going to put y'all in breakout rooms, and y'all are going to try and solve this in, what language do y'all want to use? The first time I did it in Python. Obviously, I don't think y'all should do that, but.
Probably JS.
JavaScript.
Yeah.
Cool, JavaScript it is. So
There are other languages.
Yes, lol script, lol code.
Lol code.
want
Can has scores.
I want all the solutions in lol code.
OMG WTF scores.
Let's see. Automatically design 2 to 3 participants per room. 1 to 2 to 3. There we go. Cool beans. I'll pop in, see how y'all are doing. I'm gonna give you 10 minutes, and if you don't get all the way, it's okay. Set timer for 10 minutes.
Okay, 10 minutes and counting.
I shouldn't do this. Do, 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 do.
Array or a new hash, I guess, that then you would sort by those scores.
So how's this going, guys?
We're kind of brainstorming how we would kind of start it, and then, yeah.
What's your thoughts?
Shelly just gave a thought, which was honestly kind of funny because I was thinking like a completely different way.
Yeah, I'm sure there's
And
multiple ways.
yeah, I'm sure there's a bunch, but I was like, once I heard hers, I was like, that sounds like it would work too.
And what is it?
So I was just saying, I'd take like the array, each user's array, and sort it. So like the top one is first, and then make it a key value pair of that user's name and then their top score, and take that.
So you would sort the whole array first, and then just take the top ones out of it?
For like each user, just take the top score. But I guess the same user could have like multiple of the top.
Oh,
scores.
in this case, we don't know what the users are. It's just an array of scores. That's it. Remember that array of scores is just like 1, 7 to 8, 1, 2. So we don't know anything about users in this case. We simplified it a little.
Saying it was like each user was going to send an array of like all their scores.
Nope, not quite. Yeah, so that's not going to do the trick quite yet. Or
Is it possible to post those notes that you had of the problem?
Yep. Give me a second. I'm gonna just Slack them to you because I think
Cool.
most people had them. Or I'll put them on the chat.
Cool. Yeah, no, I was definitely not writing it down. I was trying to listen.
Sorry about that.
Yeah, that's good.
But yeah, I was thinking some kind of like a reduce, but instead of adding up all of the scores, each time you hit like the top score, that's like kind of your return number. And then I guess you could have a hash too. But I was thinking of it more in a reduce kind of sense.
So, I mean, if we're just trying to show a leaderboard,
I'll let you all keep talking about it. I'm gonna go into another group. We'll run through the whole problem afterwards. So.
yeah, sounds good.
Sweet.
Yeah.
How are we doing in here? What are we thinking?
Hello.
We got some ideas.
All right, so any ideas?
Kyle, you want to take us away?
Take us away, Kyle.
So my thoughts were that, like, you make a function that takes in an array of the high scores, it takes in a max score, and then it takes in the amount you want to present. So then you would iterate through that array and select all the scores that are equal to your max score. And if they are, I would push those into a new array. And then I would check that array's length to see if it matches your amount you want to present on the leaderboard. And then if it doesn't, then I guess you go back through and see if the number equals your max score minus 1.
Interesting. I'd have to think of like the implications of all that.
Mm-hmm.
Maybe do you have any code that you've written out?
Not much. No, we just got a whiteboard.
That's okay. Do you have a whiteboard you could show me?
Not that you'll be able to read.
Oh, okay.
Let me see if I can pull up a VS Code real quick.
Cool.
Yeah, we had like literally just pulled it up.
And we've got 3 minutes left, 4 minutes. But yeah, I'm curious what your strategy was here. Actually, better yet, I'm going to let y'all keep working through it. And when we get in a group all together, we'll kind of run through all the different ideas that people have. And then what we're going to do is we're going to go through and we're going to talk about the big O implications of that. So
okay.
I'm going to go ahead and pop it to the other group. Keep working on it. See if you can get like a solution, even if it's just a whiteboarded out solution that you can show me.
Okay.
And show the group. All right, later.
I almost feel like you need another number to stick in there to replace the +1 that you can index or increment in order to have it keep going up the list. You know what I mean?
The for loop will keep it going up the list, won't it?
Well, I think like if you if you in between lines 4 and 5, if you made a new line that was like let n equal 1, and then
sorted scores. So what are you doing here?
So for us, other than, well, I mean, the easiest way to do this, we're trying to just create our own sort method, but the easiest way I was thinking is just you got your array of scores, you sort them, and then you just take the first 50. Then you're done.
Okay. How would you sort them?
That's what we're trying to figure out. I mean, obviously, the way I would do it right now is just do dot sort. But
okay.
Yeah, that's not
cheating.
That's cheating.
It's not that it's cheating. It's actually not cheating. It's just not going to do what you want it to do as it gets huge. So we're ending pretty soon here.
John, I had an idea that I wanted to run by you. Like if this was like truly like a list of like thousands of scores, like would it make sense to like first do like a select iterable to like cut down that number by like like eliminate all scores that are under 50 if we're talking about like a leader score where the scores go up to 100. That way you're only dealing with people that have scored like at a certain threshold.
Yeah, so that's one way of doing it. There's just a better way of doing it than that, because that's less flexible, and you still have to run through every term in there. When you're doing a dot select, you have to check each element, like, does this element meet the conditions? Does this element meet the condition? Does this element meet the conditions? And you have to do that with each element of the array anyways. And there's just another solution that is the same time complexity as that will finish the job.
Try to think back to those.
Why don't we know what our max score is going to be. Why don't we just go through and find all of our max scores, or anytime you meet a max, that's going through it more than once then.
Yeah, you're getting close.
It's like if you just pull all the max scores, then decrement by 1, then pull the next one down until you hit 50, then those are your top scores.
Yeah, you're getting close.
Or I guess if you just go through it once, you could set it all to like a hash map. That'd be weird.
Yeah, I think that you just said you hit the nail on the head with the hash map.
Just set every score, and then all you need to do is just pull the ones that match your highest scores. Like,
I think that's you're you're very close to the right way of doing this, or the way that at least I think is a great way of doing it.
So like the keys would be the scores, and then like the
Yes.
values, like the number of
The value would be
like
the
number
count of the
scores.
amount of times that score.
Oh,
Yeah, so,
So-
you'd have like I've got 17 perfect scores, 12 next
Yep.
to perfect.
so,
And
so
then
make
once you hit
sorted.
50.
Bingo.
So make sorted scores an empty object, and then we can
I'm gonna
do,
end
like,
these breakout
sorted
rooms, but
score-
it's gonna take a second to close all the rooms anyways.
Okay.
So I'll leave with y'all. Well, I'll see who's leaving. I imagine people are gonna hang around in there because they're probably going to want to finish up their thoughts. So, but yes, long story short, you're on the right track.
Okay. So yeah, we need to create.
Are a lot of these
object.
complicated algos solved by like solved correctly, or like in the scope of like with big O in mind by doing hash maps like this?
It's tough to say. Sometimes it's fun to use hash maps. This is a strong use case for one, because you want something that won't grow in time complexity as the array grows.
How do you then tie, if we're just tying each score to a count, how do we tie it to each user then individually too without having to go through?
We'll run through it in a second. Okay, so first question is, how did that go for everybody? Cool. So what we're going to do is we are going to program it now. So I'm going to go into the chat before I actually do anything. I'm going to steal my information so that way I actually know what to do here. I am going to share my screen now. Boop, 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 bam. We're going to go into a REPL. Go to a Node.js. Doop, doop, doop. Whoa, that don't look so good. Oh man, that really, that hurts my soul, whatever happened. You score between 1 and 100 points. Okay, got it. Wonder if these cool. So now take all that commented out. Okay, that looks way less scary now. So we're gonna want this. We're gonna start with these variables. We're gonna say let our max score equal 10. Let my scores equal that. Let's make this more JavaScripty. Cool. We're going to delete all this shit. And then we were going to say let's do a what was the other variable? We have the max score. Scores displayed. Amount scores equals, we'll do top 20. Top 5. Awesome. I don't know why this is looking all fucky here. Let me just make sure things are working, because sometimes REPL could just be kind of weird. Yeah, I'm going to copy this and paste it. Refresh the page. It's being weird. I refuse to look at that linter for that long. Oh, goddamn. Oh, my God. It hates me. Darn REPL! All right. There we go. Looks much nicer. So we're going to create a function. We're going to call it leaderboard. Bam, bam. This leaderboard is going to take an argument of max score, amount of scores, and it's going to take my scores. We'll just say scores array is what I'll call that. Scores array. And cool. So what we want to do is we want to make sure that if we call leaderboard on our current max score, our amount of scores, and our, well, we called it my scores, right? We want to get the top 5 out of here. So this should return 5, or let's see, 10, 9, 9, 7, 7, right? That's what this should return, because those are our top 5 scores. Okay. What's step 1? Well, I think that I'm going to go by what I saw people doing. So there's a few different routes that I saw people thinking. One of the routes was, okay, well, the first thing that we'll do is let's sort this guy. Let's say my scores, my sorted scores equals my scores dot sort. Sort is a iterable that takes in A and B, and then you just choose the order. So in this case, it would be A to B. And let's actually just go ahead and console.log that so we know what's going on. Console.log my sorted scores. So let's see if the sort worked. Cool, the sort works, but it's backwards. So maybe I should change this from B to A so that way I go in descending order. Yeah, I like that. How can I grab the first few scores there?
Do like a slice of the first 5 index points.
Okay, so I'm going to put it in the console.log so I can kind of check and see what's going on. So I could say dot slice, and then if I go 0 to, I don't know, let's say max, let's say amount of scores. Yeah, I like that. 0 dot amount of scores. See if that works. Cool. I have 1, 2, 3, 4, 5. So that looks good. That's doing exactly what we want. 10, 9, 7, 7, 7. All right. What happens as this gets huge, though? Let's think about this. This is where big O notation comes in. So this dot sort, right? We're using a general array sorting algorithm, and we don't really know how that works. And it's pretty likely that if we have a huge array, it's not going to be the most efficient way of doing this. Why? Let's think about how sorting algorithms work for a second. I actually want to go to YouTube, and I found something that is pretty cool. Let's look up a quick sort, which... Ooh, this will be cool. So this is going to show you how you go through an array. Oh, and it sounds really weird too. So what this is showing is, I'm going to turn off that horrible music. This is showing how you're checking stuff, how you're going through, and how you're figuring out moving these numbers around. The thing that I want y'all to visualize is look how freaking long it takes, right? This is a quick sort. I don't know that this is the fastest algorithm, but I think it's a pretty standard representation of what a lot of sorts can be like. And if you look at the time complexity, you could actually go to big O. Actually, a better thing to look at would be what kind of sort is dot sort in JavaScript. I'm curious. It uses quick sort and insertion sort for smaller arrays. So let's actually see what that does. If I go to quick sort time complexity, think there's, oh, yep, this is a cheat sheet here. This thing is great. So if I look at a quick sort has a time complexity of best case n to the log of n, which if we look at this, that's sort of like what it's saying is as my input grows, this is how much more expensive the algorithm becomes, right? We definitely could go more deeper into exactly what big O is at a certain point. But what we want to shoot for, ideally in this case, is O to the n. And I just happen to know that there is a situation where we can do O to the n. And O to the n effectively means, let's say my algorithm is 1,000,000 scores to sort through, then that means that it only increases by like 1,000,000 operations, not like 1,000,000 times 1,000,000 or 1,000,000 times some value. It basically increases by some factor of like 1,000,000. I'm not doing a great job at explaining that, but it doesn't increase as fast as this does. And this is a quick sort right here. I think it'll make a little bit more sense once I actually start going through and showing you what an O to the n looks like. So this problem can be solved in O to the n. The way that we do that is with a thing called a hash map. So this sorted scores, what it probably does is it does something like, oh, this is a simplified version of how a sort works, but it might run through and say, oh, let me compare these two numbers. Okay, which of these bigger two numbers is it? Then it's going to swap these numbers. Then it's going to compare these two numbers. It's going to see which is bigger. It's going to swap them. And then it goes through the whole thing multiple times until it actually checks to see that this one is smaller than this one, is smaller than this one, is smaller than this one. And without knowing too much about how to actually build that algorithm, you probably can infer that it takes a lot of steps to actually sort that thing out, right? Now imagine you have this, but it's 1,000,000 terms, right? That's going to be very, very expensive. What if instead I create an object? In my object, what I do is I will take this object, let's call this my score values. And now I have only 100, this thing will be 100 different answers, or I'm sorry, 10 different answers. So I could have 1 and let's say 0. Let's do something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll go 10, 0. So let's say this is a map that I set up for myself. And inside of this map, I say, how many scores of 1 do I have? How many scores of 2 do I have? How many scores of 3 do I have? How many scores of 4 do I have? And so on and so forth. Well, let's go through this array for a second. Okay, I have 110. I'm going to hit 5, and I'm going to say, okay, I have 1.5. I have 1.2. Now I have 1.3. 7, so I have a 7. Cool. And then I have 2 9s in a row, so I'm going to do there. Bam. And then I have a 7, so I'm going to increment 7 from 1 to 2. And then I have a 6 here, so that's going to be a 1, right? Well, now I have this thing that's tracking my values, right? So what does that mean? Now I have this guy. I only went through this array. Let's say this array is 1,000,000 terms long. I only went through it once in order to actually get these values tabulated, right? So then the next step, all I have to do is, starting from the largest number, I'll just say, okay, well, I have 110, so that's the first score. and then I have 2 9s. So, whoops. So that means I put that in there twice. And then I have 0 8s, 2 7s. And it looks like I just hit my max. Let's think about what this would look like if this were a million terms long. Rather than iterate here, then iterate there, then iterate there, then iterate there, then check all of that, go back, sweep through, and run through this whole array, cycling back and forth, I am running through this whole array once. That's it. That's what makes it O to the n, is that I have to run through this whole array once, and then I have to pull out all these values once. So that is what makes it O to the n. What would make it like O to the 1 would be if I didn't have to even do that. Like, let's say I just returned true, right? For no reason. I just decided to return true no matter how big the array was. That would be O to the 1, because it's going to run. It's not O to the 0. I apologize for saying that. It's going to be O to the 1 because it's going to return some constant value. This would be O to the n because I do have to iterate through each term in the array once, but I don't have to iterate through it an increasingly large amount of times as this thing grows. It's only by the number of terms, if that makes sense. Cool. So, great. So how do we actually code this? Well, it's pretty simple. So why don't we, inside of our function, let's create a thing called a hash map, right? So we're going to say let hash map equal an empty object, right? Then what we want to do is we want to go through this and we want to basically create this setup. So what we could do is we could set up all of this, right? So I could say let, or I don't know, maybe we'll say for let I equal 0. I is less than or equal to our max score, or I'm sorry, let's say let I equals 1. Or unless you want to, maybe we can have a score of 0 on here too. Sure, fuck it. Great. So for let I equals 0, I is less than or equal to max score. And then I++, we can say hash map of I, because I will be 0, 1, 2, 3, 4, 5. We'll say equals 0. So now we've created our hash map. Remember, our hash map is the amount of terms inside of this hash map is a constant. It's not dependent on the number of scores that you have, right? So let's say I have 1 million scores. I'm still only going to have 10 terms in my hash map, which means that its time complexity is not increasing as this input increases. Awesome. So now I have my hash map set up. Oh, whoops, this shouldn't say 0. This should say, oh yeah, no, we do want it to equal 0. Cool. Then what we need to do is we need to iterate through my scores. So I could just do a for each loop. I could say my scores dot for each score. We're going to say hash map indexed at score is going to equal a hash map indexed at score plus 1. Let's break down that line for a second. So let's say we're starting off, my score is 10, the first term. I'm saying the hash map indexed at 10 is going to increment itself by 1. Then we're going to get to the next one, 5. I'm going to say the hash map at 5 is going to increment itself to 1. Great. Now, how do I get back so now what I need to do is I need to get back an array of, let's see what we get. Let's see what we get back from our hash map. Actually, would be a really good, strong idea to go over. Hash map. So let's go. Actually, if I return it, then we'll be able to see it. Hash map. And remember, it should basically look like this if we did it right. So let's see. Uh-oh.
Sorry.
Someone do something bad? Cool, and look at that. We got what we thought. Now, how do I transform this back into an array in a JavaScripty way where I can start thinking about how I'm going to get my stuff back? How do I start turning this back into an array? This is where maybe JavaScript isn't the nicest at this. Ruby might be better, but anybody have an idea? Let's try this. See what that does. Okay. So now I have an array of those keys, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if I do values? Now I have an array of those values. Okay, that's a good start, right? Well, so what can we do? Let's think. I actually want to say what we can do is if we have the keys and we have the values, we can iterate through them and maybe get back a full array. So let's see what we could do here. I can say, I'm trying to think of the efficient way to do this. Let's just turn it back into like, well, let's do something that just makes it easier to look at. So what I'm going to say is return object.keys, and then I'm going to of hash map. And then we are going to map over this. And we want to say for each key, let's go ahead and return an object with our key and then hash map index.key. See what that looks like. Key H is not defined. Cool, well that's a little more readable, right? So now I know, okay, 0 has been called 0 times, 1 has been called 1 time, 2 has been called 1 time, 3 has been called 1 time. That's useful, right? We can reverse this. So, I don't know, maybe we can do a dot reverse here. So, the dot reverse would be on this array. So I pop it on the map, right? Whoops. I have to invoke it. Cool, so now it's going from 10 to 0. What would happen if I just sliced the first 5? Would that work?
No, because some of the values have more than one.
Mm-hmm. So we probably need to iterate through that again. So this would be a strong example where maybe we would want to, and by the way, I wouldn't do it this way. I just think it's easier to show this way because now you can sort of see what I'm going to slice through. So I'm going to say for, let's say, actually this might be a really good use case for a while loop. While, let's make a return scores. Return, or let's call it the scores equals an array. We're going to say while scores dot length is less than or equal to max score. I haven't made a while loop in forever, so forgive me if I mess it up. We could say scores well, we will say, yep.
You want it to equal amount scores, not max score, right?
You're right. Put some space here. Also, this should be a let.
That'll be amount scores.
What?
Amount scores.
Oops, thanks. So now what we're going to say is we want to push. Oh, we returned this, so we need to call this something else. Let's say our scores. What will we call this? Scores array equals that. And we could probably just use a const there. So while our scores.length is less than the amount of scores, we just need to go ahead and push into our scores however many times it equals that. So we could say scores array dot push. This is not a good way of doing it with a while loop. This actually is a strong use case for not using a while loop now that I think about it. Let's talk about why. We'll get back to it in a second. We'll figure it out in a second. We'll refactor it. We're going to say scores array dot push. Well, we have to say, yeah, I think it just doesn't make sense as a while loop, really. I'm going to say for each term of our scores array, scores array dot for each. We're going to call it score hash, I guess is what it is. And then we have to go into another for each, or for, no, we do want to do a for loop though. For let I equals, I guess, we want to iterate from these 0. No, yeah, 0. I is less than this value here, which would be score hash dot oh yeah, I would say object dot, so weird. This is not going as smooth as I would have thought, but object dot values. It's really not a good way of doing it, but it'll work. Indexed at 0. So we're grabbing the first value. So let's talk about this for a second, and then we're gonna say I++. Boop, boop, boop. So what I'm gonna do is I'm gonna start, let's say I'm in this guy, right? I wanna start at 0. And if this is 0, I don't wanna add anything, right? But if it's, say, 1, I wanna add it once. So what I'm saying is let I equal 0 and I is less than or equal to, is what I'll probably need, that value. if I do object.values of this hash, then it would probably be a better idea would be this. Something, well, I don't know, whatever. I'm not going to change it at this point. But it's iterating through that. And then all I need to do is say push scores dot push, and we want to push that value. So in this case, it would be score hash, but we'd have to say object dot keys score hash, and then indexed at 0. And that looks fucking hideous. I could definitely do that better. Scores array. Already been declared.
You declared it up in the argument of the leaderboard. I think if you change scores array to like my scores up there in the argument, then you could use it.
Yeah, I think you're right. Let's call this. Where else did I use this? Oh, yeah. Yep, you're right. Am I returning something somewhere?
You're returning scores array because you have scores array const on line 17, so you can't change it. So you can just return that whole for each, can't you?
What happens when you return a for each?
Oh, wait, yeah, it'll do everything.
Scores is what we want. There to go. So now we're returning all of the scores sorted, and then now we just need to slice it. Dot slice 0 to 5. Or whoops, not 5. It would be 0 to amount scores. And something looks wrong. I think this should just be a less than. Yep. All right. So I kind of cruised through that. Does anybody have questions? I hope you have questions because I feel like I did a terrible job explaining what I was doing as I was going. I know one of y'all has questions. Oh my God, Ahmed's been here. Ahmed, do you have any? Yeah.
So like this solution takes up like less, or it's faster than the one that we had worked out at the beginning with like
It's
the
not
sort.
necessarily that it's faster. It's that it's faster as the input argument gets huge. So if we wind up having 1,000,000 scores instead of, 10 scores, then it's faster. If we wind up having only 10 scores, it might actually be faster to just do the dot sort. And this is the huge concept behind Big O, is you're talking about how the algorithm changes depending on how many scores, in this case, you have to go through. So if we had 1,000,000 terms here, we would only have to go through my scores once. We would only have to go through all of them once. And then what we would get is, let's say I had 1,000,000 scores in here. Maybe I have like 100,000 perfect scores, right? And then I have, 200,000 zeros, whatever. That's a really bad distribution. It's probably a really weird game if that's how it plays. But the point is now I'm left with this this hash map of only 10 different scores that I have to go through. And even if I have 1,000,000 scores that I'm going through, this hash map only has, 10 different values that it could possibly be. So I'm not iterating through a million different things multiple times. I'm only iterating through that million value array once. And for the rest of the calculation, I'm just iterating through these 10 scores. Or if I had 100 scores, it would be 100 scores. But still, when you're talking about 100 scores, you're talking about way less iterations. And on top of that, because we controlled the order in which we put these in the hash map, we also control the order in which they get spit out from the hash map. That means that since we controlled this order, right? This goes 0, 1, 2, 3, 4. I don't even have to sort that ever. So there's no part of here where I'm really doing some kind of advanced sort. It's just that this is sorted by default because of how we set up our for loop. Does that make sense? It's kind of a trippy concept, and I definitely did a really ugly job coding it. I haven't done a hash map in JavaScript in a while. I think when I did it in Python, and it actually worked really elegantly in Python. There's some stuff that you could do. Like, for example, you could do, you see how this follows an order where it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? There's a lot of languages have a function called a range, and a range is like, I could be like range of 5, and then it'll spit out 1, 2, 3, 4, 5. There's a lot of languages that have that built into it. So like in other languages, like maybe that could be prettier. Going through this could be a little prettier. But hopefully you understand the concept of, like, in this case, a hash map and how it ties into making this thing more efficient. Somebody explain to me what we did.
You took your list and basically took every value on the list and assigned it to a hash so that you only had to go through the list twice.
Mhm.
And then you used the hash to pull out the information that you needed as opposed
Did I have to go
going
through the list twice or once?
once.
Right. I only had to
Right?
go through once.
Did
Right?
I
I
say
only
twice?
did,
Or-
what?
did I say twice? Or
I did say twice.
I meant once.
Right. So I only go through the list once, and then what? What does it do?
Yeah, you map it to your hash, and then you use the hash to pull out the information that you need, which in this case is ranking the top 5 scores.
Yep. Kelsey, explain to me what we did here.
Like the same thing that TJ explained, you mean?
Yes.
Or the next step?
Yes,
Okay.
I want you to explain it again.
Okay, so we went through our list of scores and made it into a hash map using 1 through 10 as the keys of the hash map, and then pulled out all the values that were associated with the keys.
What if I had a max score of 15? What would change?
Your hash map would go up to 15 on the keys.
Mm-hmm. So let me ask you this. If I say max score equals 15, is my answer going to change?
No.
I think you are right. Cool.
How would you handle it if you? Oh, sorry. Go ahead.
You can ask your question if you want. I think she understands. I like to drill the concepts in by asking questions.
I was just gonna ask if it would if how you handled this would change if you had like an example with like a less uniform scoring system. Like if it was like 1 through 10, but maybe you could score like a 9.9 or a 9.87. Would you still like do a hash map like that, or
You sure could. You know
okay.
how you would do it?
But you'd probably do like if hash map and then the key of the score like if that exists,
What I would do for that is actually just turn it, just multiply it. So like, let's say I have, like 10.5.
Oh, okay.
I would actually multiply everything by 10, and
Just
then
to eliminate the decimal,
yep.
and then when you're returning it back, like divide it by 10.
But I will say, like, let's say it goes all the way to like 10.577 or something like that. Then that might be like, oh, okay. If I'm going to be iterating through, 11,000 different cores, it might not actually save me that much effort. So it might not be the most efficient time to use a hash map if you were doing that, right? Depending on how many scores you had, like that's where you have to start looking at things. Be like, okay, let's say my scores can go from 1 to like 1 billion, right? At that point, I would not use a hash map for that. Because now my score value, my hash map is going to be 1 billion terms long. I'm not really saving that much time. In fact, I could actually be being very wasteful. Let's say I have 1 billion different scores that I could have, and then I only have, maybe say I have 1 billion different scores that I could have, and I only have maybe like 1,000 user scores a day, right? Then it might be really wasteful for me to sit there and say, oh, okay, let me make a hash map with 1 billion different values just so I can sort 1,000 different things, right? Like that doesn't make any sense. And this is kind of like, actually, I'm really glad you asked that question because I think it's really important to consider the implications that different algorithms are going to have on your stuff. Like, why would I use this sorting algorithm here? Why wouldn't I use this sorting algorithm here? For like my typing test, for example, right? Words per minute is going to be an integer between, anywhere between 0 and, nobody types more than 1,000 words per minute. So that means, let's say in theory, I have 10,000 users on my app seeding 100 scores a day, right? Each, which is not realistic, but I got my dreams. But like, let's say that was the case, a hash map would work great because there's only a finite amount. There's really not a large amount of scores that they could possibly have, but there is a large amount of scores that will exist. You can actually get into other stuff that could improve this algorithm too, if you wanted to. Like, I bet you could use memoization here because, like, let's say you have 1,000 scores, you can check the most recent ones, put it in there somewhere. But yeah. Y'all have any more questions? Memoization is like a different thing. Kyle flew through that when he did it the other day. It's really fucking cool though. But also, there's some great videos of people who are much better at explaining this stuff than I am. They do a really good job of like drawing it out and just explaining like what's going on. I'm gonna stop the recording.